All right, so the title of our notes today is Radians. Make sure you are taking nice notes and following along. I am considering, haven't decided yet, but I'm considering collecting your notes for this unit and giving them a little grade. And if you have them, it'll be an easy grade for you. Make sure you're doing that. Okay. So I want to first start off by defining radians and talking about what is a radian. Okay. So we've mentioned the unit circle. What do you guys know about the unit circle? Okay, it's a circle. Full circle is 360 degrees. It's got a radius of 1. And one more important thing about it. It's got a center where? 0, 0. Okay. I'm not going to worry about the center in this picture, but radius of 1 is going to be really important. So here's our radius of 1. And the a radian is the angle measurement, but it relates to the distance around the circle. So if I go all the way around the circle, what do we call that distance? The circumference. And anybody remember the formula for the circumference? 2 times pi times the radius. But in this case, what's our radius? 1, right? So what's 2 times pi times 1? 2 pi. And what's an approximation for pi? 3.14. And so then 2 pi would be roughly what? 6.28. Okay. So so the distance for the radius is 1 unit, whatever the unit is, then the distance around that circle is roughly 6.28 of that same unit. Okay. So if I only travel along this circle and I'm traveling until I get to a distance of 1. So it's only a piece of that circumference. Okay. And if you're talking about a piece of the circumference, we call that arc length. So let's say the arc length is 1, then that angle measure is what we say is 1 radian. So the angle measure, 1 radian. Okay. And so that is what a radian is. It's the angle measurement in a unit circle that would give you an arc length of 1. And I'll write that down. So a radian is the angle measurement in a unit circle that gives an arc length of 1. So how many radians are in a full circle? Well, there's 360 degrees in a full circle, but how many radians, how many of these ones can you get around that whole circle? Well, what's the distance around the whole circle? 6.28, roughly. So roughly how many radians can we get? 6.28 radians, okay? More exact, we can get 2 pi radians in a full circle, and that's an angle measurement. So in degrees, which you know, a full circle is how many degrees? 360. Now I'm telling you a full circle is 2 pi radians, and so now we have a conversion factor there. we can say, well, because of this fact, 2 pi radians is equal to 360 degrees. And to simplify this even further, we're just going to divide both sides by 2, and we're going to say pi radians is equal to 180 degrees. Now, because we have two measurements for angles, and we're going to have to be able to distinguish between the two, just want to point this out. Like if I say theta is 30, would that mean 30 degrees or 30 radians? Okay, by default it's radians. If I want degrees, then I'd have to write 30 with the little degree symbol, right? So this one signifies radians. We typically don't write radians, we just write 30 or a number, and it implies radians, okay? Where this would be degrees. All right, so that's a little bit about defining what a radian is. Let's talk about how to use a radian. Yeah, you have a question? Well, can you get 400 degrees in a circle? So if you're past the 6, that means you're going around the circle more than once, right? So 30 radians, you'd be going around that circle almost 5 times, okay? All right, so let's now look at how to apply this. So in our first section, what we did is we looked at how to the standard position of an angle. And we're going to have to re-look at these things. So let's let theta be 3 pi. And we want to locate the standard position of 3 pi. When I'm working with radians, I tend to use pretty much only the x-axis. There are special cases where I'll have to use the y-axis, but you pretty much get away with just using the x-axis. And here's what I mean. So here's 0 degrees and 0 radians. It's the starting point. And it's positive, so we're still moving counterclockwise. And I think, well, okay, what would a half circle be in radians? 1 pi, which is 180 degrees, right? And so then if half a circle is 1 pi, then a full circle would be 2 pi. And what do we say? What do we call two angle measurements that are in the same position? Coterminal. Good. Don't forget that. So 0 and 2 pi are coterminal angles. We're still not at 3 pi. So then I go another half circle and I'm at 3 pi. So God bless you. Pi and 3 pi are both coterminal, and now we found its location. So I'm just going to make this a little thicker to say, okay, we're pointed this way. That's where the standard position of 3 pi is. Okay. Most of the time, though, when you're working in radians, you're going to be working with fractions. It'll look like this. It'll be theta is 7 pi over 6. And we'll have to find out where that is. And that can be a little challenging at first, but once you develop a technique on this, it actually is not too bad. And it actually becomes a little easier than degrees eventually. So here's what I do. So here's 0. I work pretty much only with the x-axis. I'm moving this direction, and I say, okay, well, then this is pi. And this is 2 pi. So on all these, I pretty much start like that. But then I have a fraction. I have 7 pi over 6, and I need to compare it with some other numbers to know, well, is it further, is it bigger or smaller than these? And when you're comparing numbers with fractions, it's better to compare them if they have the same denominator. Okay? And so right now, pi has a denominator of 1, so does 2 pi. So this is a denominator of 6, so I'm going to multiply top and bottom by 6 and write 6 pi over 6 here. And now I can compare it with 7 pi over 6 and say, oh, okay, so I've gone more than a half a circle, because a half a circle would be 6 pi over 6. So 7 pi over 6 is going to be in quadrant 3 or quadrant 4. 2 pi, if I make that a fraction over 6, would be 12 pi over 6. So is 7 pi over 6 closer to 12 pi over 6 or closer to 6 pi over 6? 6 pi over 6. And that question helped me determine that, okay, this 7 pi over 6 is going to be in quadrant 3. And I found now the standard position of 7 pi over 6. So try that again with theta equaling let's go 22 pi over 7. Find the standard position of 22 pi over 7. So what quadrant are we in? Okay, here's 0. Half circle's pi over 1. But I need to compare that to something over 7. So that would be 7 pi over 7. So we still got quite a bit of ways to go, right? So once I know, and you could do this, once you know half a circle is 7 pi over 7, you can start counting by that. So if half a circle is 7 pi over 7, add another 7 pi over 7 to get 14 pi over 7. So that's a full circle. And you could check, if I reduce that, that's going to give me 2 pi, right? And then I can add another 7 pi over 7. So 14 plus 7 was 21. So that'd be 21 pi over 7, which is still less than 22 pi over 7. If I go another half circle, add another 7, I get 28 pi over 7. And so now I can say, okay, 22 pi over 7 is between 21 pi and 28 pi over 7. And it's closer to 21, so we know it's going to be somewhere in quadrant 3. Okay. And we got our standard position. All right, what if we have something like this? Theta equals 5. Not degrees, because it doesn't have the degree symbol, so it's radians. But what's different about this one compared to 1, 2, and 3 is it doesn't have pi in it, right? And we need to be able to figure out its location. You got an idea? Why? Okay. So you still kind of start with, okay, half circle's pi, but instead of writing pi, write its approximation, which is 3.14. And so you know that, okay, half circle's 3.14, so it's more, 5's more than that. If I go a full circle, that's 2 times that, which is roughly 6.28, right? And so now the question is, well, is 5 closer to 6.28 or is it closer to 3.14? Okay, so it's well, if I put 5 over here, it's about 1.28 off, right? And if I add 1.28 to 3.14, I'm not going to make it to 5. So 5 is closer to 6.28, and so it'd be in quadrant 4. Okay. So there's your standard position and how to work with that in radians. Next topic is coterminal angles. Another thing we looked at with degrees and now need to be able to do with radians. What was the trick to finding coterminal angles? So the trick was to add or subtract a multiple of 360. Like, we didn't have to do 360, we could have done 360 plus another 360, right? So now for working in radians, what's our trick going to be? Add or subtract a multiple of 2 pi. Because 2 pi and 360 are equivalent, right? So the reason this worked with 360 is it made a full circle and you ended up back where you started. And so 2 pi is also a full circle, and you end up back where you started. And so if I have something like, so I start with, so theta is, let's call this number 5 here. And we're going to find one positive and one negative coterminal angle with 3 pi over 7. Okay. So if I want to find a positive coterminal angle with 3 pi over 7, I'm going to add 2 pi to that. Well, we start with a fraction. When you add fractions, what do you need? Common denominator. And so with radians, the common denominator is going to be important here. So I'm going to have to multiply top and bottom by 7 here. And this becomes 3 pi over 7 plus 14 pi over 7, which is 17 pi over 7. Okay. So 17 pi over 7 and 3 pi over 7 are both coterminal. They're both in the same quadrant. They're in the same exact location, pointing in the same direction. What quadrant are they both in? Quadrant 1. Okay. It's easy to tell because if you think of, picture you got 0, half circle would be 7 pi over 7. Well, 3 pi over 7 is closer to 0, so we're in quadrant 1. And so is 17 pi over 7. Now, if I needed to find a negative coterminal angle, we could start with 3 pi over 7 and now subtract 2 pi, which is the same thing as subtracting 14 pi over 7. And you end up with negative 11 pi over 7. So now all three of those angles are coterminal with each other. So it works a lot like what we did with the degrees, but we end up using 2 pi, and we actually end up using an equivalent fraction with a common denominator. Okay. The next thing we need to apply radians to are, and really important to find this one, reference angles. So if I want, say, theta equals 11 pi over 6. And I want you to find the reference angle in radians of that particular angle. We start the same way we did with degrees. What was the first thing you would do with degrees? Find the standard position, yeah. So we're going to locate our standard position. Here's 0. Go a half circle. What do I write over here? Pi, which really we should change to what? 6 pi over 6. Right? Because you got to match that denominator. And then add another 6 pi over 6 to 6 pi over 6, and you get what? 12 pi over 6, which is equivalent to 2 pi. And so 11 pi over 6 is going to be in which quadrant? 4. So somewhere right here. And our reference angle is the angle between, or it's the positive difference between these two angles. So we're going to subtract 12 pi over 6 and 11 pi over 6 and get the positive difference. What would that be? Yeah, you're just going to, because the denominator is the same, you just subtract the numerators, and 12 minus 11 is 1, and so you end up with 1 pi over 6. So we could say our reference angle, theta prime, is pi over 6. What would that be in degrees? Well, pi is equal to what? 180. So if I replace that pi with 180, I get 180 degrees over 6, which is 30 degrees. So pi over 6, which is like foreign to us, is something very familiar. It's actually 30 degrees. Okay. Let me give you one more reference angle to find. Theta equals negative let's do 15 pi over 4. Find the reference angle of negative 15 pi over 4. So what quadrant are you ending up in? Which one? The fourth quadrant? All right, let's check. So here's 0. We need to go this direction now. We need to go clockwise because it's a negative angle, right? So if I go half circle, that's negative pi, which is negative 4 pi over 4, right? We want a common denominator, so 4 is our chosen denominator. So I'm going to subtract another 4 pi over 4 to get negative 8 pi over 4 here. And still not close. Do another 4 pi over 4, subtract. You get negative 12 pi over 4. Almost there. Do it one more time. We get negative 16 pi over 4. Forgot my pi on the left side here. Okay. And so we're going to be in quadrant 1. That's where negative 15 pi over 4 is. And our reference angle this reference triangle here is going to be this difference of which two do I look at? What am I going to subtract? These two, right? Okay. And when I subtract them, don't worry about the negatives because it's going to be a positive difference, right? And so what's the reference angle going to be? Just the 1 pi over 4. So my reference angle is 1 pi over 4. And just for fun, what would that be in degrees? So pi is 180. 180 divided by 4 would be 45 degrees. Okay. Another thing that's important. And really, you should know, okay, 30, 45, and 60 are the reference angles that we come up with, right, for finding sine, cosine, tangent. So we should eventually get familiar with those in radians because they're going to come up a lot. Okay. Last thing I want to talk about is how do you convert any degrees to radians or degrees to back and forth, from radians to degrees, okay? So converting degrees, radians, back to degrees. And it really all comes down to this. 180 degrees equals pi radians. Okay. Because that's true, like if I want to find 1 degree, I'm going to divide both of these by 180, and I get 1 degree is pi over 180 radians. Okay, and that's going to be one of our keys here. And if I want just 1 radian, well, I start this. I say, well, pi is 180 degrees. So I'll divide both sides by pi to get 1 radian. And so 1 radian would be 180 degrees over pi. So these are your radians over here. So if I get to, so now when I know that, I can find anything I want. So for example, if I have 3 degrees, and I want to convert that to radians, well, that's the same thing as 3 times 1 degree. And 1 degree is pi over 180. So I'm going to replace the 1 degree with pi over 180. And I get 3 pi over 180. And I can reduce that to pi over 60 radians. So 3 degrees is pi over 60 radians. And again, the key was to plug in or multiply 3 by pi over 180. If I wanted to go the other way and say I have 2 radians and I want to change it to degrees. Well, this is the same thing as 2 times 1 radian. I'll put rad for radian, okay? And 1 radian is 180 degrees over pi. That gives me 360 degrees over pi as an answer. So now I've converted to degrees. So 2 radians is 360 over pi degrees. So what I want you to see is that what the key is, I'll highlight them. If you want to convert, you're either going to multiply by pi over 180 or you're going to multiply by 180 over pi. And to help you remember which one to choose is look at the numerator. The numerator is going to give you what you want. So if you make your numerator pi, you're converting to radians. If you make your numerator 180, then you're converting to degrees. Okay? So I'm just going to give you two examples or two sample problems to try. What number am I on? 8? Okay. So I'm going to give you 8 and 9, and then we'll finish our notes here. So 8, I'm going to say theta is, say 60 degrees. Convert that to radians. And 9, theta is going to be 5 pi over 6. Convert that to degrees. So on 8, you convert to radians. On 9, you convert to degrees. So for 8, we have degrees. We want radians. So what do I multiply 60 by? Pi over 180 degrees. And really what happens here is kind of that degree symbol cancels out and get rid of the degrees. And if you've done this kind of thing in science where you're converting degrees or those kinds of unit conversions, that's what's happening here. So you end up with 60 pi over 180. Reduce that, divide by 60, and you end up with pi over 3. So that's what 60 is in radians. And if I'm going the other direction, I have 5 pi over 6 radians. What do I multiply that by to convert to degrees? 180 over pi. And remember, we're doing this without a calculator. Okay. So let me just show you a couple tricks with that. So first of all, the pi, get rid of. And you got 5 times 180 over 6. I would encourage you to divide before you multiply. Makes it easier. Gives you smaller numbers. You can multiply 5 times 180 first, and then divide that big thing by 6, but I would divide by 6 first. And I could divide 180 by 6, and I end up with 5 times, well, 6 goes into 18 3 times, so 5 times 30, and 5 times 30 is 150. And these are degrees. Okay, so I'm going to stop there. Your homework is page 12, 1 through 27.